This lesson is on pressure in a fluid. Have a go at the starter, pause the video while you do. Okay, so what factors affect whether an object will sink or float? You might have said the mass or weight of the object. You could have said the density of the material, or the density of the material that it's in. You might have said the surface area of the object. Okay, any of those things, good ideas. Right, so fluids and pressure. First of all, a fluid is a gas or a liquid, and pressure in fluids create forces at right angles to the surface. And we looked at this last time. Pressure is equal to force divided by area. Now, there's another equation that you need for this lesson, which is P equals H rho G. P is the pressure, H is the height of the fluid above that point in it, rho, that weird P, is the density of the fluid, and G is the gravitational field strength, and we're going to take that to be 10 on Earth. Why does each of those affect the pressure in the fluid? Well, the height of the fluid above the point. If you've got more fluid above the point, then there's going to be a greater weight pushing down on that point. The density of the fluid tells us how many particles there are in a certain volume of that fluid. The more particles there are, obviously, the more pressure there's going to be. And the gravitational field strength, again, affects the weight that is pushing down on the fluid at that point in the liquid. The greater the gravitational field strength there is, the greater the weight of that fluid above. Okay, so I'd like you to have a go at answering these questions. They're all calculating the pressure. You've got the densities of the various substances given to you. Remember that G we're taking as 10 today. And remember the equation you need, P equals H rho G. Okay, so pause the video and have a go at that, and then we'll go through the answers. So question number 1, what is the pressure under 10 metres of water? So we need 10 metres times by density of water, which is 1,000, times by 10 for G, and that gives us 100,000 pascals. Question 2, what's the pressure under 15 metres of oil? So the pressure is going to be 15 times 862 times by 10, and that gives us 129,300 pascals. Question 3, what is the pressure under 5 metres of air? So 5 times 1.2 times 10 gives us 60 pascals. Question 4, what's the pressure under 100 metres of water? So that will be 100 times 1,000 times 10, which should give us 1 million pascals. Question 5, the pressure under 70 metres of oil, 70 times 862 times 10. And that gives us 603,400 pascals. Then finally, the pressure of 200 metres of air, 200 times 1.2 times 10 gives us 2,400 pascals. Okay, so if we think about a ball that's been thrown into a pond, top of the ball is 0.1 metres below the surface, the bottom is 0.15 metres below the surface. The density of water, as we know, is 1,000 kilograms per metre cube. What is the pressure on the top and the bottom of the ball, and how can that help explain floating? So have a go at answering those questions, and then we'll have a look at the answers. Okay, you should have calculated that the pressure on the top of the ball is 1,000 newtons per metre squared, and the pressure on the bottom of the ball is 1,500 newtons per metre squared. What that means is the pressure on the bottom is much greater than the pressure on the top, and that difference in pressure is what creates the force that we call upthrust. Okay, so that's why we only get upthrust in a liquid or a fluid, because it's about that pressure differential. Okay, the atmosphere is a thin layer of air that surrounds the Earth, and the atmosphere gets less dense as we go up in it. Okay, altitude is just the height above the Earth. Air molecules colliding with the surface create atmospheric pressure, and the number of air molecules above the surface decreases as the height of the surface above ground level increases. So as the height increases, there is always less air above a surface at that point than at a lower point. So the atmospheric pressure decreases with height. We've got less air molecules above that point the higher we go. So here is a graph showing how the atmospheric pressure changes with height. What I'd like you to do, I'd like you first of all to sketch that out into your notes, and then I'd like you to try and explain why it has that shape. Okay, so the key points you should have said are that as the altitude increases, the height of the gas above that surface, or above that point, will decrease. Okay, so there's less air above that certain point if you're higher up. You should also have realised that as the altitude increases, the density of the air at that point decreases. And remember, if there are fewer particles, there's going to be less collisions, so less pressure. Okay, I hope that makes sense. Have a go at the questions I've set you on Fronter.